This is a BMW 530e plug-in hybrid battery pack. In the last video, we tried to use a basic multimeter to take some readings of this battery pack to find out how much voltage was in the entire battery pack as well as in one of the 6 cell modules. This battery pack here contains 6 cell modules for a total of 350 volts. Each one of the modules is approximately 60 volts. And we learned that we are limited on what we can get using a multimeter. We learned that we can't simply plug into the output here and get a reading because this is essentially turned off for safety. Then we learned that we can bypass this, what BMW calls the safety box, which is essentially a pre-charge circuit with a couple contactors in there. And we could tap into the leads of the battery and get a reading that way. But it's still very primitive and not very meaningful. I mean, it's accurate voltage, but it's not very meaningful. Each one of these cell modules contains 16 individual cells. And together there's 96 cells. And so what we want to do is find a better way to get more information about this battery pack. Now, there is a way to do that. There is something called SimpBMS, which I believe stands for Simple Battery Management System. It was designed by Bree. I hope I'm pronouncing that correctly. And Tom offers the software for free on his GitHub for download. And he sells a product which is made up of software and hardware. It is something that you can buy, and it comes in different flavors. So if you have a Tesla, you can get the Tesla version of the SimpBMS. If you have a BMW i3, you can get the BMW i3 version of it, and so on. What we happen to have here is a PHEV, which is plug-in hybrid electric vehicle battery pack. So he designed a sort of generic BMW PhevBMS, and I've downloaded that. And in order to make it run, you could go out and purchase his hardware as well. But I just went out and took some baby steps and purchased something called a Teensy. So a Teensy is literally a tiny circuit board with a microcontroller on it. It's similar to Arduino. You may have heard of Arduino Uno or Arduino Dewey. From my understanding, I believe that this is like an Arduino on steroids. It lends itself better to automotive use. This chip is a bit more powerful. It can do more computations, and so Tom designed his system based around this chip. So what we're going to be doing is using a Teensy board here with a CAN bus transceiver, and together these should be enough as far as hardware goes for us to get a better reading of this battery pack. This transceiver here is for CAN bus, and vehicles starting in mid-90s, say 95 and up, have a controller area network in the cars. So it's sort of, you may have heard of wide area network, a WAN, and a LAN, local area network. One could span a city or a state or a country or the world, and a LAN is what you have a local area network like in your house or in the building of your company, if you happen to work in that type of setting. So CAN, I call it car area network, but that's just something I made up. It's really controller area network. And what are controllers? Well, modern cars have a controller for, let's say, to give off a signal when a door's unlocked, or when make the windows go up and down, or the windshield wipers work. So there's all these controllers in a car. Tons of ECMs and ECUs and body control modules and this control modules and that control module. And the way they talk, the standard is CAN bus, okay, controller area network. And bus really just means like a highway or a means of communicating, a network, or some sort of a junction box. It's not a bus like you're thinking of a Greyhound or a school bus. Anyway, we're going to use this minimal hardware. I'll show you how to hook it up and to get a better reading. And we're not going to be really using a battery management system. I don't want to play a semantics game, but it's more of a battery monitoring system. Well, whereas a BMS can control the cells and protect them, I believe with our minimal hardware here, we're just going to be able to take some more detailed readings beyond a voltage of the entire battery pack or the voltage of an individual cell module. We're actually are going to be able to get down to the cell level. All right, so we can start connecting these circuit boards using something called a breadboard. And a breadboard is very common to anyone who has any electrical engineering experience. Some of us have maybe taken an electronics course in college or high school even. But you don't have to have one of these. So I'm trying to be a minimalist here, so I'll show you how to do it without this. On my build thread, I think I have some pictures of how I use the breadboard to connect these two pieces of hardware, but that's not necessary, and I hope I can pull it off without it. So the other way to make the connection is using something called DuPont cables. I bought these on Amazon for like $6. And there's ones that are male to female ends, and there's some that are male to male ends, and there are some that are female to female. You get the idea. These come in different lengths. So basically what we're going to do is, when we get this Teensy board, all right, it gets its power using a USB cable. So I just have a simple USB cable here. And we will plug this in, and this will provide two things. One is 5 volts power to this Teensy board, and also this will be how our data gets from this Teensy board to our laptop so that we can see it and read it and analyze it. So this is a data cable and a power cable. You will find out that you may have just a USB cable for charging. So if your you're having some problems and you're not getting any data using your USB cable, keep in mind that you may just have a USB cable that is just for charging or just a bad USB cable. This one here I tested, and this is for data and charging, so I'm using this one. So this now connected to a laptop will power up this board. Now this little CAN bus transceiver needs power as well, and so what we will do is use so I have just a black and a red DuPont cable here, and if you look at this board, I'll try to put a close-up on the screen in the video, but it's labeled and it actually has a 3.3 volts in and a ground. So we'll connect to the pins. There's tiny little pins on there. We'll connect the red wire to the 3.3 volts. Obviously the colors don't matter. And the black one on the second one, which is ground. And so we're kind of building up our circuit board or circuit, whatever you want to call it. Now I believe the preferred version of a Teensy board is 3.2. So I have a 3.2. This may be a 3.2/3.3 version board, but make sure to check which version you have, and don't just follow my pinout blindly. Download a pinout diagram for your board and look at it and confirm that you're putting everything in correctly so you don't damage these little components. So this Teensy board can pass power onto another device. It actually has pins to do just that. And then the third one over is where the red wire goes, and this is just my positive. Okay, so at this point we're sending power from the Teensy board to this little CAN transceiver. Once we have the power sent going to the CAN board here, the transceiver board, we also need to do a connection for RX, which is receive, and TX, which is transmit. We're going to connect a blue cable here to the CAN RX, and then the last pin on here, and I'll share close-up pictures of this, is going to be the green one for the transmit. And so those are the 4 pins on here. And then we'll go to the other end, and I'll try to hold it just like I did before. Okay? And so there's our connection of the 2 boards, right? Now the next thing we need is we'll need to connect this CAN bus transceiver. You can use these 2 holes that you can screw into, or there's actually pins below it, and there's a CAN low and CAN high, and I like to use yellow for CAN low just because yellow and low kind of correlate in my mind. So we're going to put the yellow on the low and the blue on the high. And so, you know, obviously you build this thing up in your office in the comfort of your home before heading out or going to a garage or what have you. But I'm just trying to show you this can be done without a circuit board, hopefully. All right, so now we have these guys wired up, and we're going to put them aside, and we're going to take a look at where they plug into on the battery pack. Okay, so now looking at the battery pack, right here we have the BMW's OEM BMS, Battery Management System. And what we want here is we want to take out the blue plug, because we cannot tap in here to the front connector. I unscrewed it just to kind of make it easier to show you, but we cannot tap into here. This would receive, I believe, 12 volts, and we don't need that much. I think we only need to supply 5 volts. So we want to bypass the BMW's master BMS board. And so we're going to unplug this guy. All right. So once we have this unplugged, we need to supply on the ones on the far left. Those are going to be 2 negatives. I think this battery pack wants a separate power supply for one side and the other. So that's why we need to do 2 grounds, are the 2 outside ones. All right, I hope you guys can see that. And then after that, we have 2 red wires for 2 positive. And then we'll bring in our circuit boards here. And we have to connect the low and the high. Okay, so I will have pictures of close-ups of how to do it. I'm just kind of showing you that this is just, you know, if I was to look at the whole thing, this is how I would do it. Okay, so I apologize, this is kind of cluttered here. It's not as organized as I would have hoped for, but basically we're going to use a bench power supply to provide only 5 volts to the slave BMS boards here. Okay, that's how we need to power them on. So we can connect the black wires to the negative lead. Clips on it, and then positive here. Okay, so then we can plug in the power supply, and I've preset it on 5 volts. And so if we turn it on, hopefully you can see that it's preset to only 5 volts. And I don't think this order matters, but I'm going to connect the Teensy. You can connect the Teensy first and then turn on the power supply. It really doesn't matter. So once we have everything connected, then we can fire up our Arduino. And within Arduino IDE, or the integrated development environment, we can open up the serial monitor, and on the serial monitor we will now see a reading coming in via CAN bus through the transceiver to the Teensy and to our laptop.